Dear learners, greetings. As in the previous class, we have discussed what is the measure of variability and how do we calculate. And at that time, we talked that by and large, there are three ways of calculating the measures of variability. One is known as uh, average deviation or mean deviation. Second one is known as quartile deviation. Third one is known as standard deviation. We have also discussed one another measure of variability, that is range. So today we are going to discuss about a very important measure of variability, that is quartile deviation. So what is quartile deviation and how do we calculate? So all these we will discuss in today's class. So what is quartile deviation? What does it mean? If you see the screen, the quartile definition, may be defined as mathematically half of the difference between the upper and lower quartile. This may be elaborated further in the second point of the slide. Q is one half the scale distance between 75th and 25th percentile in a frequency distribution. So just you see the graph. So this is the whole distribution. If you see this whole distribution, so Q2, that is the midpoint of the distribution, whereas Q1 is the median of the lower part and Q3 is the median of the upper part. Let me repeat, in any distribution, Q2, that is the second quartile, Q1 first quartile, and of course Q3 third quartile. So Q2 is the midpoint, and if you will go to the lower part, Q1 is just 25% of the score, and similarly Q3 is the upper group where you will get the 75% of the score. The moment you will calculate Q, that is quartile deviation, it is also known as semi-interquartile range. So you will calculate Q as Q is equal to Q3 minus Q1 upon 2, which has been further elaborated in the next slide. So sometimes we are required to calculate quartile deviation from the group data. Sometimes we are required to calculate quartile deviation from the ungrouped data. So how to calculate quartile deviation from group data, it will be discussed later on. At this juncture of time, we are mainly focusing on how to calculate quartile deviation from the ungrouped data. So as I have mentioned, formula is Q is equal to Q3 minus Q1 upon 2. So Q1 simply 25th percentile on the score scale, Q3 75th percentile on the score scale. So what are the steps if you want to calculate Q, particularly in the ungrouped data? As you remember in the calculation of median, what we did, in fact, we arrange the score in ascending order. So in the same way, in order to calculate Q, what we have to do, the first step will be, we have to arrange the whole data set in ascending order. That is, we'll put the lowest score first, then the upper score, then the upper score, then the upper score, then the upper score, and finally the highest score. I mean, something like that. So arrange the data in ascending order. Then first of all, then after that, in the second step, you compute the median of the given data set, and median will be what, as I have just mentioned, it is the midpoint or it is the second quartile Q2. So after calculating the median of the whole data set, you compute median for the lower half of the data set, then you compute median for the upper half of the data set. So the median of the lower half of the data set will be Q1, the median of the upper half of the data set will be Q3. Then simply use the formula Q is equal to Q3 minus Q1 upon 2. So by that way you will be able to know the quartile deviation. So how to do it? Let's take some examples and let's do it. So example has been written. The numbers are 5, 7, 9, 9, 3, 5, 5, 7, 9, 6, 3. So we are required to calculate the quartile deviation for this data. So remember what I have said. First you have to arrange all the data in ascending order. So see which one is the lowest number. So it is 3. So you write 3. Then there is one more 3. You write 3. Then after 3 we have 5. So 5. One more 5. One more 5. One more 5. And then we have 6. Then we have 7. 7 two times. And then we have 9, 9, 9. So see how many data were there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now see whether you have missed or you have left some or you have included all the numbers. So calculate, just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is, you haven't missed any number. So the first step in order to calculate the quartile deviation will be you arrange the numbers in ascending order. That is, first the smallest number and then proceed to the highest number. After that, remember what I mentioned, you calculate Q2. That is the median for the whole data set. Median for whole data set. So you remember how we calculate median? So you will remember that basically median is the midpoint of the data the moment data has been arranged in ascending order. So 11 is what? An odd number, and in order to find out the median of in odd situation, so median is equal to n plus 1 upon this is n plus 1 upon 2th term. So here we have 11, so it will be 6th term, 6th one. Now you calculate which number is the 6th number. So 1, 2, 3, 4, 5, 6. So this will be simply Q2. And Q2 is what? It is the median of the whole data set. Or in other words, you can say it is the midpoint in the whole data. Now, after calculating the median, this Q2 divides this whole data into two halves. One is lower half and another one is upper half. Upper half. So, in the next step, you calculate the median of the lower half of the data. You calculate the median of the upper half of the data. So, the median of the lower half of the data will be Q1 and median of the upper half of the data will be Q3, and then we will use the formula and we will calculate quartile deviation. So, here 1, 2, 3, 4, 5 numbers are there. So, the third number will be the median of the lower part of the data. So, Q1 will be 5. Similarly, if you go to the upper group, you will find that 9 is the median of the upper part of the data. So, it is Q3. So, what you have done till now? First, you have arranged the data in ascending order. Then you have calculated the median of the whole data set. Then you have calculated the median of the lower part of the data, and you have calculated the median of the upper part of the data. Now, in the last step, you will write the formula Q is equal to Q3 minus Q1 upon 2. So, Q3 you have calculated 9, Q1 you have calculated 5. So, 9 minus 5 upon 2, that is 4 upon 2, that is finally 2. So, 2 is the quartile deviation of this whole data set. And remember what quartile deviation shows? Basically it shows the spread of the data, it shows the diversity of the data, it shows the heterogeneity in the data, and it has come out to be 2. Let's take another example and proceed. So in the second example, again we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. 11 numbers are there. So you are required to calculate the quartile deviation Q. So what you will do? Definitely, first of all, arrange the number in the ascending order, and then after arranging the numbers in the ascending order, find out Q2, that is the median of the whole data. Then see what is the median of the lower data, see what is the median of the upper data, and accordingly you use the formula Q and calculate the quartile deviation. So let me do it. First, let's arrange this whole data into ascending orders. So the moment you will see towards the data, you will find that 2 is the smallest number. So 2, but 2 is one more time, so write 2. Then if you see the data, you will find one more time there is 2. So 2 are there 3 times. So you have written 2, 2, 2. Then you will see next number is 3, and again 3 is 3 times. So 3, 3, 3. Then you come to the next number, that is 4, it's only one time. Then another number is 6, again it is only one time. Then we have 7, 7 is there 2 times, and then finally it is 8. So write 8. Now match whether you have included all the numbers or you have missed any number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Total numbers were 11. It means you haven't missed any number. Now you calculate the median of the whole data, that is Q2. Again, you remember how we calculate median? When we have odd number, we use the formula median is equal to n plus 1 upon 2th term. So n plus 1 upon 2th term, that is 11 plus 1 upon 2th term, that is the 6th term. So in this data set, the 6th number will be the median of the whole data. So count which number is the 6th number, first, second, third, fourth, fifth, sixth. So this is what Q2. So Q2, that is the median of the whole data set, you have calculated as 3. Then we have this particular Q2, this particular median in fact divides the whole data into 2 sets, lower half and upper half. So this one is the upper half and this one is the lower half. Again see, in the lower half 1, 2, 3, 4, 5 numbers are there. In the upper half 1, 2, 3, 4, 5 numbers are there. Now you have to calculate the median of the lower part as well as the median of the upper part. So again, if you see in the lower part, there are 5 numbers and 5 again is an odd number. In order to calculate the median from odd number, we use the formula n plus 1 upon 2th term. So 5 plus 1 upon 2th term, that is the third term. So third term is 2. So this is your Q1. Come to the upper part. See, there are 5 numbers. Again 5 is an odd number, and in order to get the median from odd number, we'll use the formula n plus 1 upon 2th term. So that is 5 plus 1 upon 2th term, that is the third term. So you count first, second, third. So this number 7 is your Q3. So let me repeat. Till now what we have done, we arrange the data in the ascending order. We calculate the median for the whole group, that has come out to be 3. This 3 has divided the whole data into 2 parts, lower half and upper half. In the next step, we have calculated the median of the lower part of the data, which has come out to be 2, and this will be your Q1. In the next step, we have calculated the median of the upper part of the data, which has come out to be 7. So it will be Q3. Now, in order to calculate the quartile deviation, we will use the formula Q is equal to Q3 minus Q1 upon 2, that is Q3 you have calculated 7 and Q1 you have calculated as 2. So finally 7 minus 2 upon 2, that is 2.5. So in this particular situation, the quartile deviation has been calculated as 2.5. And remember what this 2.5 shows. In fact, it shows the spread of the data. It shows the heterogeneity in the data. So more, if you will get more number, more a big number, for example 12 or 15 or 20 or like that, it means there is more heterogeneity in that data, there is more diversity and spread in that data. But if the number you are getting is small, like 2, like 1, like 1.5 or 2.5 or 3.5 or 4 or something like that, it shows that by and large the data is heterogeneous. By and large the data is homogeneous and heterogeneity is less in that. So after doing these two problems, let's proceed and let's do the third problem as well. So it's a little bit a difficult case. Why? Because number here are more, but I'm quite sure by your experiences of the previous two examples you will be able to do it. So see, first of all count how many numbers are there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 and 19. So 19 numbers in total are there. You are required to calculate the quartile deviation. So the first step will be you have to arrange this whole data into ascending order. So see which number is the smallest number, and if you will see the data minutely, you will find that 5 is the smallest number and it has appeared only once. So you write 5. After 5, see which number is there. So the moment you will see the data, you will find it is 7. So 5, 7, check whether 7 has appeared once or twice. So you can see it has appeared only once. So after 7, see which number is there. I think it is 9. Now again check whether 9 has appeared once or twice. So definitely it is only once. Then after 9, if you will see the data, you will find it is 11, and again 11 has appeared only once. Then comes 12. 12 also has appeared once. Then come 13, and if you see 13 again has appeared only once. Then you will come to the next number. So after 13 it is 14. Again 14 only once. Then you have 15, and 15 are there 2 times. So 15, 15. I think 3 times. So one more time, 15. So we have reached till 15. Now after 15, see which number is there. 16, it is only once. Then you see 17, again only once. Then you see 18, again only once. Then you see 19, again only once. And then after 19, 20 is not there, 21 is not there, 22 is not there, 23 is not there, 24 is not there. So next number is 25. So it is 25, again only once. No, it is twice. So you write once more 25. Then another number is 26. You write 26. Another number is 27. You write 27. And the highest number definitely is 28. So you write 28. Now remember, in total there were 19 numbers. So what you have to assure that you have included all the 19 numbers and you have not missed any number. So calculate how many numbers are there in your arranged data. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So total number, our total number matches. It means we haven't missed any number, and definitely every number has been included in our arranged data. So remember what you will do. First you will find the median for the whole data, which will be Q2. So median for the whole data, how you will calculate? Remember the formula, 19 is an odd number. So you will use the formula median is equal to n plus 1 upon 2th term. And n is here what? 19. So Q2 will be equal to, or median for the whole data will be equal to 19 plus 1 upon 2th term, that is 20 upon 2th term, that is the 10th term. So the median for the whole data will be the 10th term in this particular data. So you count which one is the 10th term. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is your Q2. 15 is such a number which divides the whole data into two equal parts. So count how many numbers are there below 15 and how many numbers are there, above 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Similarly, 1, 2, 3, 4, 5, 6, 7, 8, 9. So now your median has divided the whole data into two parts, lower part and the upper part. In the lower part, there are 9 numbers. In the upper part, there are 9 numbers. So first we will calculate the median of the lower part, and then we will calculate the median of the upper part. So in the lower part, there are 9 numbers. Again, 9 is not an even number, rather it is an odd number. So we will use the formula median is equal to n plus 1 upon 2th term, that is 9 plus 1 upon 2th term, that is 5th term. So count 5th term, 1, 2, 3, 4, 5. So your 5th term is Q1. So you have found Q1 as 12. Come to the upper part of the data and find out the median of the upper part of the data. Again, in upper part of the data, there are 9 numbers. So the median of the upper part will be 9 plus 1 upon 2th term, that is 10 upon 2th term, that is 5th term. So count which number has come to be the 5th term. So 1, 2, 3, 4, 5. So your Q3 comes out to be as 25. Now you are required to calculate the quartile deviation. So you will write the formula Q is equal to Q3 minus Q1 upon 2. Now you have calculated Q3 as 25. You have calculated Q1 as 12 and divided by 2. So it will be 13 divided by 2. So it is 6.5. Now one thing that I wanted to explain through this, finally you have got your quartile deviation as 6.5. In the previous two cases, in the first case we got our quartile deviation as 2. In the second case we got the quartile deviation as 2.5, but here we have got the quartile deviation as 6.5. So what does it mean in fact? It shows that in comparison to the previous two cases, in the third case, the spread of data is more. And how? If you see the data, the lowest number here is 5, you see 5, whereas the highest number is 28. It shows that there is heterogeneity in the data, and it is well explained by the numeral value that you have got from calculating the quartile deviation. So in a nutshell, let me summarize. If you have got some ungrouped data and you are required to calculate the quartile deviation from the ungrouped data, so what will you do? Just arrange the number in the ascending orders, find out the median of the whole data, then find out the median of the lower part of the data, then find out the median of the upper part of the data. So median of the lower part of the data will be Q1, median of the upper part of the data will be Q3, and finally use the formula Q is equal to Q3 minus Q1 upon 2, and definitely you will get the value of QD. And this quartile deviation value shows the spread of the data, the diversity in the data. Dear learners, this QD, this quartile deviation has so many advantages and disadvantages. So first, let me explain the advantages, then we will talk about disadvantages. The biggest advantage, it's easy to compute, it's easy to understand, it's easy to interpret, it's easy to comprehend, because just you have to arrange the data in the ascending order and you have to calculate median for the whole data, then lower part of the data, median of the lower part of the data, and median of the upper part of the data. So calculation in comparison to other measures of variability is relatively easy. Then you see this particular quartile deviation basically is useful when the distribution is skewed. The moment I explained the concept of median, I told that median is such a measure of central tendency which is very suitable in the case of a skewed case. So in the same way, quartile deviation is such a measure of variability which is most suitable in case of a skewed data. Then quartile deviation is less influenced by extreme values compared to range. So remember, yesterday I talked about range, and you know how we calculate the range? We subtract the lowest score from the highest score. So if there will be any extremely low value or any extremely high value, that is if outliers will be there in the data, definitely range will be very much influenced. But this is not the case in quartile deviation. So by the outliers or by the extreme scores, quartile deviation is less affected in comparison to other measures of variability. So it gives a better idea of variability around the mean, definitely, because our whole calculation is based on, it gives a better idea of variability around the median, and it is natural because our whole calculation is based around the median. And finally, it is appropriate for open-ended distribution. It has been, you know, there are some disadvantages as well of quartile deviation, and the biggest advantage, as in the case of median, is that it ignores 50% of the data almost and considers only the middle values. This is one of the disadvantages. It is less accurate than the standard deviation for precise studies. And what is standard deviation and how we calculate standard deviation, definitely we will discuss it in the next classes. So the moment you will compare quartile deviation with the standard deviation, you will find that standard deviation is more precise and more suitable for the further studies in comparison to the quartile deviation. It is less informative for distribution around an average. This is the third disadvantage. And finally, there might be loss of information about the tails or the extreme. But despite of all these disadvantages, definitely quartile deviation is supposed to be one of the most important measures of variability and one of the quickest ways to calculate the measure of variability. I have recommended two books. These two books are very good if you want to know further about quartile deviation. So one book, as you can see on the slide, Garrett, it's a very good book, and another one, Guilford book. Both the books are very good. So if you want to know something more about quartile deviation, definitely you can go through that book. So for today, it's enough. I think I will come in the next class with some new topic. Thank you very much. Go have a good day and take care.